of normal spoken English language into an SQL query. Let's go ahead to see the presentation. All right. So, conversion of spoken English language query into SQL. Now, databases are very common and used at a very large scale within current applications and website. So, data retrieval from database requires knowledge about the database language, that is SQL. But people who do not have any knowledge about it, they find it difficult, to structure a query and retrieve data from the database. So, researchers are trying to find out a method that bridges the gap between information needs and the user satisfaction. Now, abstract. Now, in this article, what we are doing is they have proposed a method which allows the user to access data using natural English language. So, the user submits the query in the form of speech signal, and a language model converts the speech utterance into an English sentence. Now, this English sentence is passed, and natural language expressions are converted into the SQL language. Now, this SQL query is then used to retrieve data from the database in the form of text. So, they're describing how to extract information related to a target database in order to know its structure and vocabulary, and then using the keywords and the questions asked, it will generate an output that is the most probable equivalent of the SQL query. The request will be generated based on the presence, number, and order of keywords identified in the sentence entered by the user. See, that is how it is working. That's the architecture of the model, in which we're converting the speech into text first and then this into an SQL query. So there's a speech query that goes to the speech recognition engine. There are basically two models, acoustic model and language model. That input text query goes to the text translator, which has lexer, parser, clause extractor, and table finder. Now, this language model basically includes morphological, phrase, lexical, syntactic, semantic, SQL formation, and then comes the output. So that is what happens in the speech recognition engine, and then that goes to the text translator, which gives us an output of an SQL query that is used to retrieve data from the database. So these are the components of the language model. Now, how does the system basically work? This is a diagrammatic representation. So basically the user is giving a text input or a speech input, which then through natural language processing is converted into an SQL query, which goes into the OLAP Cube data warehouse. And then data is retrieved from all of these data sources to the data warehouse, which is then given back as a data result and output to the GUI, which is then seen by the user, right? Now, the first step is to record the speech utterance of the user and convert it into text. So what we're doing is whatever the speaker is speaking, the user is speaking, we're converting it into text using Google Speech API. For this purpose, what we're using is Google Speech API. And thus we're setting the language into English US for the English United States and respectively for the other languages. So after setting the language, the speech recognizer is activated. All right. Now the second step is to recover only the meaningful words in the sentence. We do not need the entire sentence, but just the keywords or the key parts that are needed to retrieve data. So we are recovering only the meaningful words of the sentence which are entered by the user. For this, the T-tagger tool has been used to filter the empty words according to the class grammatical, that is prepositions, pronouns, determiners, etc., and perform routing of the remaining words. So let's take an example that how old are the students whose first name is Ankit. So the filter must return the elements age, pupil, first name, and Ankit. Now the third step is to recover the structure of the database on which the query has to be performed. We need to know the structure of the database or the table in which we're performing the query. That is, we need to know the columns, tables, primary, and the secondary key of that table. So that is what we're doing in the third step. So this method has been implemented to achieve the result to collect the information by querying the database using SQL queries like show table, show columns, describe, etc. Now the fourth step. What does the fourth step do is it searches for the keyword of the request entered by the user is extracted. Now the idea is to look for the correspondence between the keywords and the application of the synonyms and the entities of the database in order to perform the segmentation of demand according to the correspondences found, and thus to know a best structure of the request to generate. Now in simple words, okay, there is a database in which we are performing a query. The presence of select and from segments is mandatory in any of the basic SQL queries that we write, right? So the first designates which will be the type of selection on which elements exactly, and from determines where to look in which table, etc. So it can be noted in particular that if a request contains no words similar to table, it will be invalid or it will generate an error. All right. Now, these words can be the presence factor of a query called counting, algebraic calculations, a negation, etc., or else a value on which a constraint must be made. So in this way, if a word referring to the count as an example, so let's take an example, how much. Any normal basic English sentence is spoken in which the presence of how much word is there in the first segment of the sentence. So that corresponds to select in a normal SQL language, right? So the system identifies the request to be generated as a count request. So we're going to generate an query saying select count. Now the final step is that once a first candidate SQL query is obtained, it is run on the database. So if the request is invalid, that it is badly constructed, the system then tries to rebuild it differently. If say supposing there's a sentence which is spoken not in a much constructed way, the system will try to reconstruct it and generate a SQL query and find the valid answer from the table and try to execute it. But if it still returns an error, then the system is going to generate an error message. Thank you.